Hello everybody. Welcome to another lesson covering the topics of factors and products for the 10th grade, or if you're not in the 10th grade and just want to sharpen your knowledge, these lessons are right for you. Now, last time we focused on how to put or find the prime factorization, the greatest common factors, and whatnot of trinomials, binomials, and other nomials, right? Polynomials is what they're called. And in this one, we will be finding the factors, or just solving something very similar, and that is called multiplying binomials. Then we'll be factoring trinomials using logical reasoning. And each of those little topics have a few subtopics, if you'd call them that. And then there's multiplying polynomials, which we will just touch on. Maybe in the next lesson, we will continue on that. Now, first off, we need to know, right, if you watched the last video, you'll know what a polynomial is. It is the, I'd like to call it the equation where, this is a binomial, right? Let's say 2b, for instance, plus 4. And then over here, we have b, right? And then you just solve it by multiplying into the brackets. Anyhow. Now, multiplying binomials with positive terms. Let's do a little example. So we go in here, we have 3d plus 4, right? Times, right? Sometimes in some equations you'll have them just put a point or something. I don't personally do that. But then it's a 4d plus 3. Fairly simple. We just kind of combine them, right? So you go 12d squared, because you are having the d's be multiplied so they add together, plus 6d plus 16d plus 8. Right? That looks pretty good. But we can simplify this. We can simplify this even further, where, because 16 and 6, they both have the same, they're like terms, right? They both have a d in the singular power, right? Opposed to the 12d squared, right? So we can just go in, right, and go 12d squared plus 22d plus 8. And that would be the answer for this equation, right? This thing has a few steps that can be overwhelming, but they are not anything that we can't conquer. So, there is another point, though, where they can have negative coefficients, which are just a little fancy word for the values and just things in the equation, right? So let's say, I don't know, 2g plus 8. But let's make this 2 negative, right? 7 negative 3g. So looks very similar, but it has a few quirks to it, because you got to multiply in. You got 14g plus 6g squared, right? Because 2 negatives make it positive. 2 wrongs do make a right here. And then plus 56 and then negative 24g. Right. Obviously, these two, look at that. They are like terms. So what we're going to do, so we're going to add, right, negative 14 plus negative 24. Or, well, yeah. I'm going to put it in the middle so we can see this in like a form that looks simpler. So 6g squared, which is this 6g. And then the answer of these two, negative 38g plus 56. Yeah, I mean, it is fairly simple if you just think about it like any other one, right? But then these are binomials, right? They just have two brackets, two values. They end up being whatever, right? I like to say that these, these are the opposite of the trinomials. Anyhow, let's actually take a look at the trinomials. A trinomial, three things. So let's give an example. Let's say you have 4h squared plus 20h plus 9. Now, that is, how do we get these? What multiplied to 9 and then added to 20? Or I'll just write it down on paper. It's much easier to see. Now the answer for this would be the 2h plus 9, right? And then 2h plus 1. Let's solve this. You can figure this out because 2 times 2, 4. 2 times 1 is 2. So you have 2h, right? So, and then you go 9 times 2, h, and that is 18h, like terms. Then 9 times 1, 9. So that is the expanded form of this, and this is simplified. So that's something you'll encounter a bit, right? So, yeah, it is fairly simple once you really see it down on paper and are able to, you just understand it. I think my way of explaining it can be a bit complicated, right? Can be a bit long, but hey, right? But this form, this way I just did it, is just one of the ways you can. There's another form called decomposition, right? I personally don't usually use decomposition, right? I never really, touched on that, but for you, maybe it's easier. So let's go in here. 3s squared, negative 13s, negative 10. All right, okay. But how did we get that is the question. What was the equation that gave us this lovely answer? Now, let's go in here. Let's say, for instance, it could 3s. Oh, that's a horrible s. Plus 2. And then s negative 5, let's say. All right. So we can go in, check our work very easily. Go in 3s squared, and then negative 15, right? And then 2 times s is 2s, and then we go in at negative 10, 2 times negative 5. All right. And then that simplifies to that, because like terms, add them together. If you have a debt of $15, negative 15, and then you are given $2, that's negative 13, right? And yeah, it's not very complicated, but because it isn't very complicated, let me just squeeze in a little something more. Multiplying polynomials. This isn't something that, these are some pretty hard questions. They can be. Let's just see if we can't do a little example. This might be a bit long. Just gonna let you know. h2 plus 3h negative 4, and then 2h plus 5. Okay. All this is just a longer version of what we just did. This is trinomial, binomial, right? 2 of them here, 3 of them here. But we can solve this. So we can solve this just how we did with the other one, but it's just going to be more work. All right. So we go in h2 and then 2h. So we go 2h3. Right. And then now look at that. Of course, we have to simplify. Math is never complete until the entire equation's simplified, okay? So let's look. Let's look here. What has the same values as each other? This one, right here. This one, right here. So we just combine those, and then we'd combine these two, because they're both h squared, right? And that would leave us with 2h3 and then we would go in just like that, and then we have our answer. Now, there are other ways for us to do such things, such as having a polynomial that has more than one variable. Let's look at that. So we go in like this. Now look at this here. Look at this. These bracket. This entire bracket is to the power 2. So that's the exact same as writing it out as just so you know that multiplication's basically always in between the brackets. But yeah, it's just, it repeated itself. Yeah, and we can solve it just as easily as we did before. Right, going into there, 10G, 10R. Alright. Yep. And then, of course, simplifying. Just like that. Simple, easy, perfect, right? And I think we could have room for one more thing. Just one more. We can have a little fun, right? So this is the differences of polynomial products. Sorry if I'm cramming too much in, but it's a very important topic you learn. On a test or something, this would be an extending question, I think. But I don't really make the test, do I? Anyhow, here we go and solve it. I'll let you take a look first. Let you take a peek. All right, let's go in. And we add a big plus sign. That's usually what I put when you're adding entire equations together. And for our simplified, completely done answer, we should have just like that, right there. All right. This page is getting a bit crowded. And yeah. This might be the last lesson if I just put in this here. Squares are usually quite similar, but there are a lot of differences, like simple equation here, a2 minus b2. That's just kind of something that is said around. The most simple and common one equation that I have seen is this here. 25 minus 36x squared. So this here, what you're looking at, is a squared minus b squared. So, how do we solve this? It's just like the trinomials, but you're just working with 2. Remember how we had the thing where it's a bracket, right? Say this is in a bracket and then squared, and that's repeated. That's where we use this. Here we go in. What would multiply to 25? 5 times 5. That's right. So 5. And then we need x squared here. How are we going to get that? How are we going to get that? We're going to get it through negative 6x here, and then positive 6x here. Now, it could be argued that you shouldn't explain it like putting that there, because one's a positive, one's a negative integer, but simplest way to explain it, just for these ones, you can repeat it, but with differing integers. Anyhow, then 25 and I'm wondering, wait, what do we do with these two? I'll show you. They're gone. Done. They cancel each other out, because when 30 positive is added to negative 30, that's 0. And we don't write that. We don't write that one bit. And now we are left with 25 minus 36x squared. Simple, easy, no need to stress. Okay. Thank you for tuning in again to what is the final lesson in your journey. If you have any questions, feel free to contact my wonderful team by email or call, which is left in the website's contact section. We have worked very hard to bring this to you, and we hope that you are satisfied and you go out there and you change how you do math. You change how you do this, and you're going to do good. That's all we've wanted. Goodbye, you.